Welcome to Unit 2, Oceanographers. We're going to learn about a new focus of Earth science, including some interesting natural disasters, and of course, we're going to have a new project. But before that, we've got to actually learn our stuff. So in this unit, we are going to talk about oceanography, tsunamis, and rising ocean levels. Today is obviously going to be Intro to Oceanography. You should have guided notes that were provided to you in your checklist. Get ready to write. Let's get this done. We're going to talk about three types of characteristics: geological, chemical, and physical, as we learn about this awesome thing on Earth. First, let's do some facts. So first of all, 71% of the Earth's surface is covered with water. Obviously, 29% is covered by land. You can just look at these pictures, you're going to notice there's so much more blue than green. Now, most of the Earth's water is found in the global ocean, versus like the fresh water that would not be. And we divide these oceans into 5 different segments based off of where the continents are. They're divided by the continents. These 5 are going to be listed in decreasing order of size. So obviously the Pacific Ocean is the largest, followed by the Atlantic, the Indian, the Southern, and then the smallest, which is the Arctic Ocean at the very top of the Northern Hemisphere. Now, you don't have to write this down, but we do need to sort of recognize how oceans actually formed. So 4 billion years ago, volcanic gases, including water vapor, began to form in the Earth's atmosphere. Now, at the same time, the Earth was cooling, and that caused the water vapor to be able to condense. Now, when water vapor condenses, it forms water droplets, which formed as rain. And of course, water began to fall as rain, precipitation, and then the rain filled the basins of the Earth, the crevices that were the deepest, with water first, forming our oceans. Now, interesting fact that the global ocean covers nearly 376 million square kilometers. In comparison, the entire North American continent covers only a little bit more than 24 million square kilometers. Now, geological characteristics. We're talking about geology, rock formations, the surface of the Earth, and that below it. Okay, so geology. So as you guys did with your virtual lab, you learned throughout ocean mapping that one of the main things that scientists use to discover what the ocean bottom of the floor looks like and map it is using sonar. But they also use drills and underwater exploration vessels or satellites. So sonar, which also stands for sound, navigation, and ranging, uses sound waves to measure distances. As you said, it sort of pings it down, and as it bounces back up, it measures that distance, and that's how deep something is. Now, when we're looking at the ocean floor, there are 2 main regions. We have the continental margin, which is the edge of the continent that is covered by the ocean, and it's divided into 3 sections: the continental shelf, the continental slip, and continental rise. If you look at a picture, the continental slope is a very gentle slope. The continental shelf is a gentle slope. The continental shelf is much more steep, and then the continental rise is again a gentle slope, but it's where the trenches are not located. The second region is the deep ocean basin. Okay, so you had the continental margin, and now you have the deep ocean basin. And this, again, is the deepest parts of the ocean, and it includes 4 main features: the deep ocean trenches, abyssal plain, we have the seamounts, and mid-ocean oceanic ridges. So, deep ocean trenches, these are long, narrow depressions, and they're formed by subduction, which is one plate going underneath another plate. This is also associated with earthquakes, high heat flow, and volcanic activity. An example of this is the Marianas Trench, which is 7 kilometers below the adjacent Pacific Ocean floor. So in other words, where the trench starts, it's 7 kilometers down. That's really, really deep. Now, the abyssal plain, this is just the flat portion of the deep ocean basin. Not to say that you don't have certain things on there, but again, it's mostly flat. With seamounts, these are submerged volcanic mountains. So as you can look at the picture, as we get into the abyssal plain, there are these little peaks of higher portions of the ocean floor. They don't reach the surface of the ocean though. So they're not the volcanoes that form, let's say, islands like what we saw with Hawaii. Um, Now, mid-oceanic ridges, they're really just forms of rifts in the sea floor. Look over the picture to the right. You start out with the movement of plates away from each other that forms a rift. Magma comes through. And as the tectonic plates continue to move away, and as you know, again, you have this ocean floor that develops, you get, again, you continue to get a rift, and eventually you get that sort of mature ocean where you have a ridge, um, and the abyssal plains around it. Let's talk about the chemical characteristics of the ocean. So first of all, the chemical characteristics of the ocean include the amount and type of gases in the seawater and the amount and type of dissolved salts, or the salinity. Now, talking about gases, we're not going to spend a lot of time talking about that. Some of the reasons why you might have different amounts of gases in the water is, like, for instance, volcanoes, or places where, again, gases from the inner core escape into the surrounding water. You also might have areas of higher oxygen levels around organisms that are able to photosynthesize, our producers or our autotrophs, whether those are plant-like or whether those are protists. So that's about it that we're going to talk about gases. The main thing we're going to focus on is the salinity. Now, salinity is the amount and type of dissolved salts. So it's not just salts sitting in water, they are dissolved. And remember that water, one of the properties that we learned back in biology, is that water is a universal solvent, and that salt, again, is dissolved into it. Now, factors that affect this salinity are climate and water movement. Now, in hotter and drier climates in water, you're going to see a higher salt or salinity, because you have a higher rate of evaporation, and that is going to increase the salinity because the water evaporates and the salt's left behind in the ocean. In cooler or humid areas in water, you're going to have less salt because there's less evaporation. Now, with water movement, the focus I want you to is understand that surface water may have different levels of salinity, because not all of them are going to be the same. For instance, if you have um, water that's the open ocean surface water versus water that's in, like, a bay off the coast, that's going to have different levels of salinity. You also are going to have different levels of salinity as to where the water is in the water cycle, whether we're evaporating, whether it's precipitation and falling down, whether it's melting, whether it's coming from river runoff or groundwater or freezing water. So just take a look at this little diagram off to the side and just uh, sort of see what affects the increase and decrease of salinity. You may want to, again, sort of draw this out on your notes. It might be helpful. Now let's talk about physical characteristics. These are mainly going to be focusing on temperature and then density. So we're going to focus on temperature first. And the thing is that ocean temperatures, they're not constant, nor are they uniform. In other words, depending on where you are in the ocean, what part of the ocean, what part of the world you're in, the temperature is going to be different. Now, the temperature of the ocean water decreases as the depth of the water increases. So the deeper you go, the colder it's going to get. And we can divide this into 3 different layers. The surface zone, which is easy to remember, it's the surface. And you're going to, that's going to be heated by the sun, and it's going to be the warmest layer. Now, thermocline. Thermocline, let's break up that word. Thermo meaning heat, cline meaning increase, decrease, incline, decline. So in other words, it's a slope. And so it's saying a heat slope. This is the zone or layer that, again, the temperature drops the fastest. You can look over at this picture and just sort of see. The surface temperature sort of holds from the 100 meters down to about 200 to 300, about the same temperature. And then the deep ocean sort of holds again at that sort of same average deep temperature. But the thermocline area, you see this sort of, again, slope happening where you have higher temperatures at the very top of it, but very low temperatures at the very bottom. And then, of course, the deep zone, which is our average temp of 2 degrees Celsius, or as you can see over there, anywhere from a range of 32 to 39 degrees Fahrenheit. Now, density. Density is the measure of mass of a substance divided by the volume. In other words, D is equal to M over V. This is something that you definitely have learned in hopefully math classes like geometry, and then also if you have any physics classes, you definitely be utilizing this formula. So density depends on temperature and salinity when we're dealing with density of ocean water. Salt water is denser, more dense than fresh water because salt water contains larger amounts of dissolved solids. So it's going to have these, again, particles that are floating in there to create more atoms, which is more dense. Now, temperatures affects density more than salinity does. That's something I really want you to remember, that temperature is more, again, has a higher effect on density than salinity. Main thing is that cold water is denser than warm water. Again, cold water is denser than warm water because the water molecules are getting closer and closer together. Now, this is the tricky part, and this is where people get confused. But ice is less dense than liquid water. So that's why ice floats. And that can be confusing because what ends up happening when water gets cold enough to freeze, it forms a crystal lattice that actually forms these hydrogen bonds that makes a very structured sort of like form, what we see as ice, and it sort of expands a little. And then that's why it floats up. Now, with liquid, those water molecules are flowing and they're just a whole lot closer together, but they're not locked in. So again, cold water is, again, more dense than warm water, and ice is actually the least dense of them all. Besides, obviously, air. I mean, water vapor is gas and spread out. Now, when we talk about latitudes, surface water is warmest near the equator and coldest near the poles. That's what I was talking about, temperature also being regulated based off of where in the world. And that's just based off of the direction of where the sun is hitting the earth. And of course, by season, surface water is warmest in the summer and coldest in the winter. Remember that the northern hemisphere and the southern hemisphere have different summer months and winter months from each other. They're not the same. In other words, we have summer, high summer is like June, July, and August. That's like winter time in the southern hemisphere. All right, these are the ends of your notes. Hopefully it helped you better understand the ocean before we actually get into the other characteristics next lesson, where we talk about currents, waves, tides, and obviously the biggest wave of them all, tsunamis. All right, have a great day.